One fine evening, a group of 5 students have been discussing about their calculus assignment. However, they have yet to find an application of calculus in their daily life.
Guys, I can't find anything.
I can't find anything.
Yeah, us too.
I've got an idea. Why not we play some fireworks?
But how can we apply firework in calculus?
I'll show you.
Ni apa tapi
Calculation.
I'm feeling tired. I'm going back.
Bye.
Bye.
Have you ever wondered at what height do fireworks explode? Well, to determine the maximum height of a firework when it explodes, we must first study the trajectory of the firework. The firework's path is a parabola. The distance between where the firework was launched and where it landed is approximately 6 meters. In our discussion, let 1 unit on the Cartesian plane equal to 1 meter. Using this information, we can theorize that the path is similar to the equation y is equal to negative 1 over 2 x squared plus with 3x. Differentiating this equation forms the first derivative, dy over dx, which is negative x plus with 3. The first derivative is the gradient function of the parabola, which means at any point on the curve, the gradient of the tangent at any point satisfies the first derivative. To calculate the turning point of the firework's path, the tangent to the curve must be horizontal, parallel to the x-axis. Hence, at the turning point, the first derivative is equal to 0. By solving for x, we get x with the value of 3 at the turning point. To determine its y-coordinate, unknown x in the original curve equation is substituted with 3, resulting in the value 4.5. Therefore, the coordinates of the turning point is 3 and 4.5. As an additional confirmatory test, the second derivative can be obtained to determine whether the turning point is a maximum or a minimum point. By differentiating the first derivative, we get the second derivative, which is negative 1. Negative 1 is a value less than 0. This indicates the turning point is indeed a maximum point, which is consistent with our observations. Hence, the maximum point of firework where it exploded is 4.5 meters above the ground.
Oh no, I'm already late. Can you give us a lift?
Sure. Come on.
While the coffee is brewing, we realized that this could also be applied in calculus. Any idea how? Well, have you ever wondered of what is the maximum volume of coffee that can fit in the cup? Let's find out!
Integration can be used to calculate the volume of an object from its 2D image using the formula volume equals to pi times the integral from a to b of x squared dy. To calculate the volume of the cup, we first have to look at its cross-section. The base of the cup has a diameter of 5.7 centimeters, a height of 11.3 centimeters, and the lid of the cup has a diameter of 8.8 centimeters. The cross-section is in the shape of a trapezium ABCD. The line that indicates the height of the cup is located in the center of both diameters and is a perpendicular bisector of both lines. The cross-section is also symmetrical on both sides of this line. Hence, let's assume this line as the y-axis. To form an equation representing the slope of the cup, we need to extrapolate both lines until it intersects with the y-axis, which forms a triangle. Now, we face a problem of finding the height of the entire triangle to be able to determine the y values for the coordinates of point A, B, C, and D. The trapezium ABCD consists of a rectangle and two identical right-angle triangles. The length of the base of the triangle is 1.55 centimeters, while its height remains at 11.3 centimeters. The larger extrapolated triangle, however, has a base length of 4.4 centimeters and an unknown height labeled as h. Since both of these triangles are congruent, the ratio of the height of the triangle to its base length is equal. Hence, we can calculate the value of h to be 32.077 centimeters. With the value of h figured out, we can plot the points on a Cartesian plane. The coordinates of points A, B, C, and D are negative 4.4, 32.077, 4.4, 32.077, negative 2.85, 20.777, and lastly 2.85, 20.777 respectively. Hence, to find the gradient of the slope line, we can use the coordinates B and D, and by substituting into the formula, we get a gradient of 7.29. Therefore, the equation of the slope line is y equals to 7.29x. We now have to rearrange the equation of the slope line to make x as the subject. Then, by squaring both sides, we can get the equation x squared equals to y squared over 53.1441. Now, with an equation at hand, we can find the volume of the cup. But wait, we lack another information, which is the interval consisting of the upper limit and lower limit from the y values of the coordinates b and d. The lower limit indicated by A is 20.777, while the upper limit indicated by B is 32.077. By substituting all these values into the formula, we can find the volume of the cup. Hence, the maximum volume of the cup is 473.63 cm3 or 473.63 milliliters.